point x0 comma y0. So tangent plane and the given function will behave same at the point x0 comma y0. This is the target of linearization. Now we see some of the examples of linearization. Here example 1 is find linearization of f of x comma y is equal to e raised to x into cos y at the point 0 comma pi by 2. Now we will solve this example. Table 2 please. Find linearization of f of x comma y is equal to e raised to x into cos y at the point 0 comma pi by 2. This is the question. We will solve this. First we write, we know that linearization of any two variable function at any point x0 comma y0 is given by if L of x comma y is equal to f of x0 comma y0 plus fx at x0 comma y0 into x minus x0 plus fy at x0 comma y0 into y minus y0. This is the formula to find the linearization of any function. So in order to find the linearization of f of xy is equal to e raised to x into cos y at 0 comma pi by 2, we have to find all these things: f of x0 comma y0, fx at x0 y0, fy at x0 y0. So here f of x comma y is e raised to x into cos y, and the point x0 comma y0 is equal to 0 comma pi by 2. Table 2 please. Now we will find all these things: f of x0 y0, fx at x0 y0, and fy at x0 y0. f of x0 comma y0, which is here f of 0 comma pi by 2, because x0 is 0, y0 is pi by 2. So which is same as putting in this function we have e raised to 0 into cos pi by 2. E raised to 0 is 0, cos pi by 2 is e raised to 0 is 1, cos pi by 2 is 0. So final answer is 0. Thus f of x0 comma y0 is 0. Next we find fx at x comma y. That means partial differentiation of the function f of x comma y with respect to x. This is e raised to x into cos y, because differentiation of e raised to x is e raised to x, and cos y will work as a constant here, so it is as it is. Now we want to find fx at x0 comma y0. That means fx at 0 comma pi by 2 is equal to e raised to 0 into cos pi by 2, which is 0. Thus fx at x0 comma y0 is 0. Now we find fy at x0 comma y0. Before that we find fy at xy. That means partial differentiation of f of xy with respect to y. Here e raised to x is constant, so it is as it is, and differentiation of cos y is minus sin y with respect to y. So finally it is e raised to x minus sin y. Now we find fy at 0 comma pi by 2, which is same as e raised to 0 minus is here into sin pi by 2. We know that e raised to 0 is 1 and sin pi by 2 is also 1. So final answer is minus 1. So Fy at 0 comma pi by 2 is minus 1. So now we will put all these values in our equation number 1. That is here L of xy is equal to f of x0 comma y0 plus fx x naught at x naught comma y naught into x minus x0 plus fy at x naught comma y naught into y minus y0. So putting all this value, we have linearization L of x comma y is equal to f of x0 comma y0, that we have find here f of x0 comma y0 is 0. So first term is 0. Next, fx at x0 comma y0, but fx at x0 comma y0 is 0. So this term is 0 into x minus x0, that means x minus 0 plus fy at x0 comma y0, that is here fy at 0 comma pi by 2 is minus 1. So it is minus 1 into y minus y0, this is y minus pi by 2. So simplifying this, we have 0 0 pi by 2 minus y. So this function L of xy is equal to pi by 2 minus y gives the linearization of the given function e raised to x into cos y at the point 0 comma pi by 2. We can verify that this function L of xy will behave almost same at the point 0 comma pi by 2 with the given function e raised to x into cos y. Let us verify this. We have to verify that f of xy is similar to L of xy at 0 comma pi by 2, that means at given point. We have f of xy is e raised to x into cos y, but f of x0 comma y0 is f of 0 comma pi by 2, that is here f of 0 comma pi by 2, that is 0. So this function is 0 at this point 0 comma pi by 2, and L of xy, that is we have derived here L of xy is equal to pi by 2 minus y. Now pi by 2 minus y at this point 0 comma pi by 2 is pi by 2 minus pi by 2, that means 0. So this is also 0. So these both numbers are similar at this point 0 comma pi by 2. Now we see one more example of linearization. Slide please. Here question is, find linearization of f of x comma y comma z is equal to sin xy upon z at pi by 2 comma 1 comma 1. That means given function is of 3 variable and we have to find the linearization. Table 2 please. Question is, f of x comma y comma z is equal to sin xy upon z. We have to find linearization of this point at the point pi by 2 comma 1 comma 1. First of all, we will write down the formula to find linearization for 3 variable function. We know that linearization of any 3 variable function at some point x naught, y naught, z naught is given by L of x comma y comma z is equal to f of x naught comma y naught comma z naught plus fx at x naught comma y naught comma z naught into x minus x0 plus fy at x naught comma y naught comma z naught into y minus y0 plus fz at x0 comma y0 comma z0 at z minus z0. This is the formula to find out linearization of any three variable function. So we need to find all these things: f at x naught, y naught, z naught, fx at this point, fy at this point, and fz at this point. So we will try to find these things. Here, first of all, we will find f of x naught, y naught, z naught, which is here f of pi by 2 comma 1 comma 1. Here the function is f of x y z is equal to sin x y upon z. So x equal to pi by 2, y equal to 1, and z equal to 1. So putting all these things, we have sin pi by 2 into 1 upon 1, that is sin pi by 2, that is 1. So f at x naught, y naught, z naught is 1. Now we need to find this thing fx at x naught comma y naught comma z naught. Now fx at x comma y comma z, that means partial differentiation of function f with respect to x, that is differentiation of sin xy upon z with respect to x only. So differentiation of sin xy is cos xy, and again differentiation of x into y with respect to x is y, so it is y only upon z, because z is constant here. So fx at x y z is this. We want to find actually fx at this point pi by 2 comma 1 comma 1. So this implies 1 into cos pi by 2 upon 1. Now cos pi by 2 is 0, so final answer is 0. Similarly, we will find fy at x y z, that means partial differentiation of f of x y z is equal to sin xy with respect to y, and keeping all the variables as a constant. So differentiation of sin xy with respect to y is cos xy, and again differentiation of x into y with respect to y is x upon z. So fy at pi by 2 comma 1 comma 1 is pi by 2 into cos pi by 2 upon 1, but cos pi by 2 is 0, so final answer is 0. So we have fy at this point is 0. Next we find fz. Now fz at x y z, that means differentiation of function f of x y z is equal to sin xy upon z with respect to z. It is here sin xy will work as a constant, so sin xy as it is, and differentiation of 1 upon z is minus 1 upon z square. So this is the partial differentiation of f with respect to z. Now we want to find fz at this point pi by 2 comma 1 comma 1. So it is actually minus 1 upon 1 into sin pi by 2 into 1. This is the theta hour. So minus 1 into sin pi by 2. Sin pi by 2 is 1, so final answer is minus 1. So we have derived all the things: fx at x0 y0 z0, fy at x0 y0 z0, and fz at x0 y0 z0. Now we will put all these things in the linearization formula. Let us write down again linearization formula for any 3 variable function. This is the linearization. L of x comma y comma z is equal to f of x0 comma y0 comma z0 plus fx at x0 y0 z0 into x minus x0 plus fy at x0 y0 z0 into y minus y0 plus fz at x0 comma y0 comma z0 into z minus z0. All the things we have present now. So f of x0 comma y0 comma z0 is you see here f of x0 y0 z0 is 1. So here f of x0 y0 z0 is equal to 1 plus fx at x0 y0 z0. This is the fx at x0 y0 z0, that is 0. So this term is 0 into x minus x0, that means x minus pi by 2 plus fy at x0 y0 z0, but fy at x0 y0 z0 is 0. So this term is 0 plus fz at x0 y0 z0, and fz at x0 y0 z0, that means fz at this point is equal to minus 1. So this term is minus 1 into z minus z0, z0 is 1. So this is minus 1 into z minus 1. So after simplification we have 1 plus this term is 0, this term is 0, and 1 minus z. So this is 1 minus z, and finally it is 2 minus z, that is nothing but the linearization L of x comma y comma z. So this represents the linearization of given any 3 variable function at the given point. So in this way we can find the linearization of any 2 variable or 3 variable function using the application of partial differentiation. This was the topic of linearization. I will finish my discussion for linearization today. Thank you.